Controlled Environment Plant Production Engineering Technology Education modules are developed and presented by the Ohio State University, Rutgers, and the University of Arizona with support from USDA and NIFA through their Higher Education Challenge Grant Program. This module was developed and presented by Dr. Murat Kasira of the University of Arizona, Dr. A.J. Boat of Rutgers, and Dr. Cherry Kubota of the University of Arizona. In this module, we are going to discuss about units and some of the terminology. Units allow us to compare quantities that are not in the same space, place, or time. When we look at quantities that are measured or calculated, they must be given proper units. A measurement without a unit specification really does not make much sense. We're going to see that there are several unit systems used to present quantities. As the society and economy are becoming more global in scope, it is really increasingly important to fully understand unit systems and to accurately and conveniently convert from one unit system to another. The learning objectives of this module is to define the terms quantity, value, and unit, to perform addition, subtraction, multiplication, and division on values with units, and to convert quantities from one set of units to another using appropriate conversion factors, and to become familiar with components of different unit systems as they are particularly related to controlled environments. To understand the world of quantitative analysis, it is necessary to comprehend some of the terminology. Let's look at this example as the statement states that the length of the greenhouse is 30 meters. The property that is measured is called the quantity, and in this example, the length of the greenhouse is the quantity. Any measured or counted quantity has a value and a unit. The value is the actual numerical quantity, and the unit is a description of what the quantity is of. In this example, as you can see, the 30 is the value of the quantity and meters is the unit being measured. We will discuss about unit systems and unit conversions later in the presentation. However, let's mention here that 1 meter in International Unit System equals to 3.28 feet, which is in British Unit System. If a value does not have a unit attached, then it is called a unitless or dimensionless value. As seen in this example, the transmissivity, which is the quantity being presented as the property of the glazing of the greenhouse, is 0.9, which is a dimensionless value. A quantity can be a basic property or basic quantity, such as length, time, mass, or temperature, or it can be a multiplication or division of basic properties, such as density as the ratio of mass and volume, or in the case of velocity, which is the ratio of length and time. Values with units can be added, subtracted, multiplied, and divided. In the case of addition and subtraction, the values may be added or subtracted only if the units match. On the other hand, the numerical values and units may be combined using multiplication and division with no regard to whether or not the units match. Through multiplication and division, the end result may leave the value dimensionless or with a brand new type of unit. As you can see in this example, for instance, the length of an object times its width gives the area of the object, or the work results when a force acting upon an object to cause a displacement. Here the unit for force is represented by Newton and the displacement is represented by meters. Therefore, the amount of work is represented by a Nev unit, which is Newton meters. Another example would be the velocity of an object, which is obtained by dividing the distance traveled to the time of the travel. And the new resulting units for the velocity becomes meters per second. A measured quantity with a value and specific unit can be converted into any unit of the same dimension using a conversion factor, which is the ratio between two expressions of the same quantity but different units. Let's consider an example here, converting 2.4 meters into centimeters. Since 1 meter equals to 100 centimeter, therefore 100 is the conversion factor between these two units. So 2.4 meter times the conversion factor, 100 centimeters, to 1 meter, the meter unit cancels out, resulting in 240 centimeters. Therefore 2.4 meter equals to 240 centimeters. Using the same method, one can convert a compound or derived unit to another derived unit. As shown here in this example, we can convert from miles per hour to meters per second. For instance, 45 miles per hour times 1 mile equals to 1609.3 meters, so the mile unit cancels out, times 1 hour equals to 3600 seconds, therefore the hour unit cancels out, leaving the resulting value and the unit as 20.12 meters per second. There are two major unit systems that are widespread in today's engineering and sciences arenas. The most well-known system of units are the International System of Units, what is better known as the SI unit system, and the British unit system. The SI unit system is founded on 7 SI base units for 7 base quantities that are assumed to be mutually independent. The base units in SI systems are the meter, which is the unit for the length. The kilogram is the SI base unit of mass. The second is the unit for time. The ampere is the SI base unit relating to electrical current. The Kelvin is the SI base unit relating to thermodynamic temperature. The candela is the SI base unit relating to luminous intensity, and the mole is the amount of substance of a system. The table on this slide shows the base units in SI system and corresponding units in the British unit system as well. The British unit system uses the foot as the base unit for length, the pound mass for the mass, and Fahrenheit for the temperature. The conversion factors can be used to convert units between these two unit systems. Units of various sizes are commonly formed by the use of prefixes. The prefixes precede a basic unit of measure to indicate a multiple or fraction of the unit. Each prefix has a unique symbol that is attached to the unit system. The prefix kilo, for example, may be added to gram to indicate multiplication by 1000. 1 kilogram is equal to 1000 grams. The prefix centi likewise may be added to meter to indicate division by 100. Then 1 centimeter is equal to 100 of a meter. Other quantities called derived quantities are defined in terms of 7 base quantities. When base quantities are multiplied or divided, a compound or derived quantity is obtained. This table presents some of the common derived quantities, for instance, volume, force, pressure, energy, and power. The table also presents the units used for each given derived quantity for two different unit systems. As you can see, the liter and gallon for volume in SI and British unit system. Newton is used for force in SI unit system, while pound force is used for British unit system. Pascal for SI unit system, and pounds per square inch in British unit system for pressure. The energy is represented by joules in SI unit system, while it is BTUs, British thermal units, in British unit system. The watt unit is used for power in SI unit system, while horsepower is the unit for power in British unit system. The table also presents the symbols used for units as well as the equivalent units in both unit systems. Some area units of interest in controlled environment agriculture, for example, 1 meter square, 1 R represented by A, and that's equal to 100 meters square. 1 decare is represented by dA here, and 1 decare is equal to 1000 meters square. 1 hectare represented by HA, and 1 hectare is equal to 10,000 meters square. Another unit used in controlled environment agriculture is 1 acre, and 1 hectare, for example, is equal to 2.47 acres, and that's equal to 107,639 square foot. We can also look at some derived SI units of interest in controlled environment agriculture. For example, the area in terms of meter square or hectare, or other area units that were mentioned in the previous slide. In the case of force, the unit for force is Newton with a symbol of N, and 1 Newton is equal to 1 kilogram meters per second square. The work is represented by the unit of joules with a symbol of J, and 1 joules also equals to 1 Newton meters. The power is represented by the unit watts, and 1 watt is equal to 1 joules per second. When it comes to light intensity, we represent light intensity in terms of irradiance. For example, the amount of power received by a unit area basis. In this case, the unit is watts per meter square. Or we can also represent the light intensity in terms of the number of photons received per unit area per time basis. For example, if you're talking and trying to quantify the photosynthetic active radiation, the PAR is normally quantified as micromoles of photons received by per unit area per time basis, and that's actually a measure of the photosynthetic photon flux density, or ppfd. Since photosynthesis is a quantum process, therefore ppfd is generally used by plant biologists. Both watts per meter square and micromoles meter square per second provide the instantaneous light intensity levels. However, they can be integrated over time to give the accumulated light levels. We can represent volume with liters with a symbol of L, and the pressure in SI units as derived SI unit is represented by unit Pascal, the symbol PA, and 1 Pascal is equal to 1 Newton per meter square. And as we mentioned, these are some of the derived SI units used in controlled environment agriculture, and one can also search for other derived SI units. As we mentioned earlier in the presentation, it is important to fully understand the unit systems and to accurately and conveniently convert from one unit system to another. This slide presents some of the conversions from SI to British unit systems. For example, if we want to convert the temperature in SI units from degrees Celsius to Fahrenheit, the conversion is 1 degree Celsius equals to the value of temperature in Fahrenheit minus 32 times 5/9. We can convert from hectare to acre. 1 hectare is equal to 2.47 acres. 1 kilogram equals to 2.2 pounds. If we want to convert the volume in liters to gallons, for example, 1 liter equal to 0.264 gallons. And we can also convert from meter to feet. 1 meter is equal to 3.28 feet. You can also search for other conversion factors and equations to convert from SI units to British unit system. Thank you for listening.